All right, so this is section 5.2 still, but this is going over the examples from example 2. There's just two. Before we go over those two, I want to kind of review how we simplify numbers in a radical. Okay, so let's pretend we have the square root of 288. Now we should all know how to do this by now. Okay, I'm going to show you two ways to do it. Whatever way you'd like, do it. By all means, but there are two different ways that I think you've been shown, hopefully. Okay, so some of you can look at this and say, oh yeah, well, the square root of 288, 288, that is the same thing as the square root of 144 times 2. Okay, and when we multiply under the radical, we can actually separate them. Square root of 144 times the square root of 2, and then we all know that square root of 144 is 12. So the square root of 288 simplifies to 12 times the square root of 2. Okay, so that's one method we have shown you. Now, let me change colors. The other method we've shown you is the cake method. Okay, and so that's where we have 288, and then we break it down into its prime factorization. So here, they're only prime numbers. Okay, so like we can clearly see this is an even number, so 2 goes into 288. 288 divided by 2 is 144. Okay, 2 goes into 144 72 times. 2 goes into 72 36 times. 2 goes into 36 18 times. 2 goes into that 9 times. 3 goes into 9 3 times. 3 goes into 3 once. When we get to 1, we're done. Okay, now because we are talking about square roots here, that's what we're comfortable with, so think of that as a 2 there if you want. What we did is we pulled out 2's. Okay, and we said, okay, well, we have a pair of 2's, a pair of 2's, and a pair of 3's, so those come up front. So out front we'd have 2 times 2 times 3, and then on the inside we'd have a 2. So what is that? 4 times 3 is 12, square root of 2. That would be our answer. Okay, so notice both of these are the same. Now, there's advantages and disadvantages of both. There's times that I personally feel that this method is definitely easier. This would be one of those times. But there are other times that I feel this method is easier. So, like I said, this is a matter of preference. Okay, so when we talk about third and fourth roots, it would be the same thing, except rather than picking pairs, like if we were doing cubed roots, you would find groups of 3. Or if we were doing fourth roots, you'd find groups of 4. Okay, but the process is still the same. All right, so let's go ahead and look at this now. Let's look at A. Okay, so we have the cubed root of 4 times the cubed root of 128. Okay, so the first thing I'm going to do is since these both are to the third power, I'm going to make this the third root of 4 times 128. Okay, 4 times 128 is the cubed root of 512. Okay, so now it's just a matter of simplifying 512. Okay, so I'm going to break it down over here. 5, 1, 2. So clearly 2 goes into 512 because it's even. So 512 divided by 2 is 256. And clearly 2 goes into that 128 times. And 2 goes into that 64 times. 2 goes into 64, 32. 2 goes into 32, 16 times. 2 goes into 16, 8 times. 2 goes into 8, 4 times. 2, 2, 2, 1. All right, so now we've broken it down to the prime factorization. Now, since this is to the third power, we will go in circle groups of 3. So we have 3 2's, 3 more 2's, and 3 more 2's, no leftover, so there's not going to be a radical. So our answer here is just 2 times 2 times 2. We're going to multiply all those groups of 3, which is, what, 8. All right, let's look at part B now. Okay, because these are both the same, we can actually put these together. So 192 over 6. Okay, well, if we divide 192 divided by 6, we find that that is actually 32. Okay, and some of you may know the fifth root of 32 is 2. I don't. So if we wanted to break it down, we could do 2, 16, 2, 8. 2 goes into 8 4 times, 2 goes into 4 twice, 2 goes into 2 once we're done. We're looking for groups of 5, so 1, 2, 3, 4, 5. We'd circle all those. We'd have no leftovers, so nothing would go in a radical, so this is just 2.